Hi friends, in this video we are going to discuss about how to get the impedance parameters or how to calculate the impedance parameters from the given network. So we know that two-port network means the network consisting of two ports. So we are calling as two-port network, and in this particular network we are having port 1 in the left side and port 2 in the right side, and the voltage we are applying in the port 1 side is V1 and in the port 2 side is V2, and current supplied by port 1 voltage is I1, current supplied by port 2 voltage is I2. Now our target is to find the impedance parameters from this particular given network, and we know that the value of 10 ohms given, here 15 ohms given, and this one is the 5 ohms given. Now total how many parameters are there means, so totally Z11, Z12, Z21 and Z22. So totally we are having 4 impedance parameters are there, and our target is to find all these 4 impedance parameters from this particular network. Now we know that the standard expressions given by the Z parameters are, so V1 is equal to Z11 I1 plus Z12 I2, V2 is equal to Z21 I1 plus Z22 I2. Now these are the standard equations under Z parameters concept. Okay. Now we know that Z11 is a parameter, Z12, Z21, Z22. So from this we need to get all these parameters, and we know that in order to get the value of Z11 and Z21 we need to open circuit port 2. If you are opening the port 2 means in open circuit there is no flow of current. So that is the reason why in order to find Z11, Z21, just we are going to open circuiting the port 2. If we are open circuiting means the value of I2 is equal to 0. Now I2 is equal to 0 means we need to substitute that value in place of I2 in equation number 1 and 2. You will get the parameters. So this is the concept actually we are following to get the value of Z11, Z21. Now in order to get the value of Z12 and Z22, so we need to open circuit port 1, and open circuiting port 1 means the value of I1 is equal to 0, and substitute this I1 is equal to 0 in equation number 1 and 2. You will get the remaining 2 parameters, those are Z12 and Z22. Okay, now our target is to find all these parameters in this particular given network. Now how we are going to finding all these parameters from this particular network? So this is the most important concept we are following to get all these impedance parameters, and the most important point is how we are going to getting the impedance parameter from the given network. So that is the most important point. Okay, now see here. Now again I am going to redrawing this particular network to find the value of Z11 and Z21. Now what I am doing in case number 1, okay, I am considering as case number 1. So in case number 1 what I am doing, so open circuit port 2. So port 2 we are opening means the value of I2 is equal to 0. Okay, so the value of I2 is equal to 0 because we are opening the port 2. Now we are I am going to redrawing this particular network like this. Now see, now so here we are having the resistance. So this one is the 15 ohms, this one is 5 ohms, and this one is the 10 ohms. So here we are applying V1 and I1 is flowing. Now we are open circuited, okay, open circuited port 2. Port 2 means that is what, I2 is equal to 0. I2 is equal to 0 means this particular value of I2 flowing in the network, I2 is equal to 0. Okay, now in order to get the impedance parameter Z11 and Z21, just apply KVL in loop 1, you will get one parameter, and coming to the another parameter, what we need to do? So actually we are applying voltage V2 in the port number 2, but we do not have, simply we can say that we are opening this particular port 2 means, so we do not have the voltage, value which is available in the right side. Okay, that is in the port 2 side. Now our target is to find this particular 2 parameter from this particular case number 1. Okay, now open circuiting port 2, that is I2 is equal to 0. Now apply KVL in loop number 1. Okay, now see here. So now this is the actual circuit. Now again I am redrawing here. Now listen carefully, because if you are understood with the help of this particular problem, then everything is very simple. Okay, now so this one is 10 ohms and the value of I1 is flowing, and we are having the voltage V1. Okay, now what I am doing, apply KVL in loop number 1. Okay, so apply KVL in loop number 1. So what is the Kirchhoff voltage law definition? Applied voltage must be is equal to drop across individual elements. Okay, now here the value of I2 is equal to 0. Okay, now see, when we are open circuiting port 2 means this complete port 2 voltage is don't know, and the value of I2 is equal to 0. Now if you are going to apply KVL in loop number 1, how you will get? So by KVL in loop 1. Okay, so by KVL in loop 1 you will get, so V1 is equal to 10 into I1 plus 5 into I1. Okay, so here why we are not taking this value of I2 means, actually just see, I1 is incoming to this value, and I2 is also incoming to this particular node point. Okay, I1 is coming to node point, I2 is also coming to node point. After reaching this node point, both the currents are flowing through what? 5 ohms only. It means I1 plus I2, both currents are flowing through 5 ohms. But we know that port 2 is opening means the value of I2 is 0. Okay, the value of I2 is 0 means the current flowing through 5 ohms now is only I1 only. So that is the reason why I1 flowing through 10 ohms, that is 10 into I1 here, and because of I2 is equal to 0, so the value of I1 which is flowing through 5 ohms, now that is 5 into I1. Okay, now here I1 is equal to, so 10 into I1 plus 5 into I2, it will gives the value as 15 into I1. Okay, now here V1 is equal to 15 I1 means, so here I am writing like this. So V1 divided by I1 is equal to 15. Now we know that V1 by I1 is what? Z11. Okay, now see here. So like this we need to get the value of what? Impedance Z11. Now Z11 is equal to V1 divided by I1, that is equal to 15 ohms. Now we already solved in the previous video what is Z11, what is Z12, what is Z22, what is Z21, everything we'll discuss in the previous video. If you have any doubts, just go through my video, and that video link is available in this video description. Okay, now this is the value of Z11. Finally we got the voltage drop across 5 ohms, that is current flowing through 5 ohms, and current flowing through 5 ohms multiplied with 5 ohms, it will give the value of what? Voltage drop across 5 ohms. That particular voltage drop directly appear across these two terminals, these two open terminals. So that is the reason why, how we can say that, how we can write V2 is equal to 5 into I1, because we know the formula, that is V is equal to I into R. Okay, so V2 is equal to 5 into I1. So V2 is the voltage across open terminals. Now the voltage drop appearing across the open terminal is what? The voltage drop across 5 ohms. So that is the reason why V2 is equal to 5 into I1. So V2 is equal to 5 into I1. Now here V2 divided by I1. Okay, V2 divided by I1 is equal to 5. Now we know that V2 divided by I1 means Z21. Okay, now from this Z21 is equal to 5 ohms. Okay. Now this is the value of what? Impedance parameter, another impedance parameter value. Okay. Now this is what? Parameters we got when we are open circuiting port 2. Now another we required another 2 parameter. Those are what? So calculation of Z12 we required, as well as calculation of Z22 is also required. Now go for the calculation of these two. Okay. So how we are going to get these two parameters? Same. Now we need to open circuit to port 1, and whatever the procedure we are following in this case, in case number 1, same procedure we need to follow in case number 2. Okay. Now see here. So calculation of another 2 parameters. Calculation of another 2 parameters here. So again I am going to redrawing. So case 2. So case 2, that is open circuit port 1. That is what? Open circuiting port 1 means the value of I1 is equal to 0. Okay. The value of I1 is equal to 0. Now see here, if I am going to redrawing the network, it will becomes like this. Just see here. So this is the resistance connected between two. Okay. Now this part, port 1 is what? Open circuited. Open circuited means the current flowing from this port 1 is 0. But here the value of I2 is flowing, because in this case V2 is acting. Okay. V2 supplying the voltage. Now here I2 will give the value of current which is flowing. Now this particular value is 15 ohms. This one is 5 ohms. This one is 10 ohms. Okay. Now apply KVL in equation in loop number 2. Okay. Now see here. So apply Kirchhoff's voltage law in loop 2. Now apply Kirchhoff's voltage law in loop 2. Now we know that by application of, or by applying KVL, you will get, so V2 is equal to, so 15 into I2 plus 5 into I2, because I2 is supplying by what? Supplying by V2. That is the reason why I2 is incoming to this node point, and here I1 is also incoming to this particular node 1. But we know that the value of I1 is equal to 0 because of open circuiting port 1. It means whenever these two currents are reaching the node point, then the current flowing through 5 ohms is I1 plus I2. But we know that I1 is 0 means 0 plus I2. It means current flowing through 5 ohms is what now? Only I2. So that is the reason why when port 2 is acting, when port 1 is open circuiting, then V2 is equal to 15 into I2 plus 5 into I2. Now I got a expression like this. Now V2 is equal to 15 I2 plus 5 I2. It will gives 20 I2. Now here, so we can write V2 divided by I2 is equal to 20. Now we know that V2 divided by I2 means the parameter is Z22. Okay. So here the value of Z22 is equal to 20 ohms. Okay. Now this is the value of what? Z22. Now coming to another last parameter. So that parameter always you will get whenever we are going to consider the voltage drop across 5 ohms directly appearing across this terminal, open terminal, that for example we are considering as terminal A and B. So in order to find the remaining parameter, we need to consider how much voltage drop we are getting across this terminal, across this particular open terminals. So with the help of that only we will get the another parameter. So that is the reason why in order to get the voltage drop across this terminal, how we are going to get? So whatever the voltage drop we are getting across this particular 5 ohms, and this particular 5 ohm is directly connected across the open terminal. It means the voltage drop across 5 ohms directly it will appear across this particular open terminal. So that is the reason why we can say that. So this one is V means, so we can say that. So V1 is equal to 5 into I2. Okay. So V1 is equal to 5 into I2 because current flowing through 5 current flowing through 5 ohms into the value of 5 ohms, it will give a voltage drop. So that particular voltage drop directly appearing across the open terminals of a port 1. So V1 is equal to 5 into I2. Now from this we can write V1 divided by I2 is equal to 5. And we know that V1 divided by I2 means, so this one is Z12. Okay, now here Z12 is equal to 5 ohms. Now this is the value of another last parameter. Okay, now finally we got the Z parameters. Finally we got the Z parameters. Z parameters are, so Z11 is equal to 15 ohms. Now Z12 is equal to 5 ohms. Z21 is equal to 5 ohms, and Z22 is equal to 20 ohms. And we already discussed about the most important condition, that is the mutual impedance connected between the two ports, that is Z12 and Z21 must be same. I already told you in the previous video. So here Z21 must be is equal to Z12, that is what, 5 ohms. So like this we need to find the impedance parameters from any two-port network like this. So thank you so much for watching, and please do subscribe my channel. Thank you.